Hello, this movie is for Learning Target 3, Triangle Congruence using Angle Side Angle and Angle Angle Side. We're going to start off with Angle Angle Side, and what that means is if I have two angles with the included side meaning the side between the two angles, congruent to two angles in its included side of another triangle, then it's a shortcut way to prove the two triangles congruent. So let's look down here. Which two triangles are congruent by angle side angle? Well, we can see this first one, I'll call it triangles 1, 2, and 3. Triangle 1 has angle side angle, so that seems to work. Triangle 2 also has angle side angle, where the sides are the included between the two angles. But look at triangle 3. I've got two angles and then a side, so triangle 3 does not work. It must be these two. So let's write a congruent statement. Let's write triangle UVS congruent to, and the other triangle needs to be written so that corresponding parts align. So we'll start with E, because E corresponds with U. And then what corresponds with V? We've got O and then N. So that's called a congruent statement. Which two triangles are congruent by angle side angle? Angle side angle, let's look at triangles 1, 2, and 3. 1 has angle side angle, 2 has side angle angle, 3 has angle side angle. So this one does not work. It's 1 and 3. And let's write our congruent statement. Triangle GHO is congruent to, how must you write the other one? Well, if I started with G, I have to start with C. And then H corresponds with A, and then T. And that's your congruent statement. Here, let's walk through a proof. We've got, and I'm going to do this because I don't want to write all of the given. We've got angle CAB congruent to DAE, that's marked on the diagram. BA congruent to EA, marked on the diagram, and A and E are right angles. So, given 2, what allows us to say angle B congruent to angle E? Well, I'm given that they're both right angles, and we know that all right angles are congruent. It's actually one of the theorems we went through, and I said please don't waste memory space, because it is something we already know. All right angles are in fact congruent. Now, knowing that these two angles are congruent, do we have a shortcut way to prove the two triangles congruent? We do. We have angle side angle. Let's go to the next page. We're going to do a proof with this. Building a miniature golf course at your town's youth center. So here we have a design. We've got all of this is given. So number 1 is given. Now, do we have it marked on the diagram? It's kind of hard to see. Let me actually do it in white. It might be a little easier. We've got AB congruent to DE. Angle A is congruent to angle D. Angle B and angle E are right angles. So we got these two as right angles. What allows you to say B congruent to E? All right angles are congruent. And then if we have that, what makes the two triangles congruent? Angle, side, angle. We also learned in one of our shortcut investigations that angle, angle, side also works. Now what that means is we have two angles and then a side congruent to two angles and then a side. It's a shortcut way to prove the two triangles congruent. Let's look at a proof for that theorem. Here we have two triangles, A congruent to D, B congruent to E, AC congruent to DF. And notice I like to walk through the given again and remark the diagram, because then that helps my brain know what's already given. And all of those are listed down here on the side. The fact that A is congruent to D and B is congruent to E allows me to say angle C must be congruent to angle F, because if I have two angles of one triangle congruent to two angles of another, then the third angles must be congruent. So this is by third angles theorem. Now that I have C congruent to F, I can prove the two triangles congruent by, let's see what I have. I have side angle side. Nope, I just have one side. Sorry, angle side angle. Ooh, angle side angle theorem. So that's not something I'm allowed to use. So I can't write angle side angle, but I've got a lot of things that I could write. So you see how we've got angle side angle angle. What if I used, angle side angle? Because I'm trying to prove the angle side. So I don't need to use that. I could use angle side angle. And that proves the two triangles congruent. Let's do another proof. This one is a classic one because it incorporates what we've used in Unit 3. We've got M is, let's mark it, M is congruent to K. That's given, so let's write given. Now, I've got these two lines parallel. And again, what I like to do with parallel lines is extend them beyond the diagram, highlight them so I can see that they are in fact parallel. Now, I've got this transversal, so I want to highlight that as well, because I think that's important to see as well. Now, these are parallel because of given as well. Now, what allows you to say angle MWR, this angle, I'm going to do two arcs, is congruent to KRW. KRW, these two arcs there. So what allows you to say those two angles are congruent? Now think back to Unit 3. You've got parallel lines cut by the transversal. What allows you to say those two angles are congruent? Well, those two angles are alternate interior angles. So when lines are parallel, alternate interior angles are congruent when lines are parallel. Now, what allows you to say WR congruent to WR? Well, it's congruent to itself, so it's reflexive. Now, do we have a shortcut to prove these two triangles congruent? Well, I've got angle, 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 side congruent to angle, angle, side. So that's my shortcut, angle, angle, side. Okay, let's go to the next page. Here we have another proof. We're given S congruent to Q. Let's make sure that's marked. S congruent to Q. And we're given that RP bisects SRQ. If I go to S to R to Q, that's talking about this whole angle right here. So PR is bisecting that. What does it mean to bisect? It means to cut it in half. So this is given. What allows you to say SRP congruent to angle QRP? These two angles can be congruent based on a term that you have in number 1. So this is because of definition of bisects. We had that PR bisects that whole angle, so therefore the two angles are congruent by definition of bisector. RP congruent to RP. This side is congruent to itself by reflexive property. And then the two triangles are congruent to each other based on angle, angle, side. Angle, angle, side congruent to angle, angle, side. All right. On the next slide, I would like you to pause the movie, try this on your own, press play when you are finished. All right, use the diagram at the right. Which following statements best represent the answer and justification to Are these two congruent? Well, I've got angle, angle, side here. And notice that I'm going from 2 to 1 to side. Down here, I go from 1 to 2 to side. So this is no, because FB and OT are not corresponding sides. So I've got angle, angle, side and angle, angle, side. It's just that they're not corresponding sides. So the answer should be B. Now, if I had this side congruent to this one, then that would be angle, angle, side. Are these two triangles congruent? Explain. Well, from what we're given right now, we only have an angle and a side. But we know vertical angles are congruent, so let's mark that. And then let's see if we have a shortcut. Oh, well, not only that, I mean, we do have angle, angle, side right now, but I could do third angles theorem to get angle P congruent to angle S, and then I could even have side angles or angle, side, angle. So this is yes, we could put right now by angle, angle, side. But we could also use third angles theorem to get P congruent to S. Which two triangles are congruent by angle, side, angle? Well, this first one I've got angle, side, angle, angle, side, angle. In the last triangle, the bottom one, I've got angle, angle, side. So that can't be. So it's going to be triangle ABC is congruent to triangle. I started with A, so I need to start with J. And then B corresponds with K, and then L. That's my congruent statement. This next page, I'm leaving these two as practice proofs. If you would like to practice working on proofs, I know they're hard to make up, so I wanted to give you some extra ones throughout this unit. These are going to be practice proofs. Thank you for watching.